Hi everyone. In this video I'm going over 7.1, 7.2, and 7.3. If you're like I was, you might need more practice at factoring. Factoring is something we were doing in the last set of videos. So in this new chapter, we are going to get even more opportunities to get even better at factoring. So we're going to be trying to simplify rational expressions. And not only that, as in this first problem, we're going to state any excluded values. Something that you might remember from our in-class discussion is that we're not mathematically allowed to divide by 0. So if I take like 8 divided by 0, I'll get this math error. If I take even 0 divided by 0, I'll get this math error. Any number divided by 0, like 8, I guess I already did, 9 divided by 0, you're going to get this error because it's just not a real thing. We can't take 0 parts. Well, I should say we can't cut up something into 0 parts and then somehow take 9 of them. So what we're going to do is make sure that whatever values come in for x, that we do not divide by 0 when those values come in. So what I'll think about is, okay, we have x minus 7 in the denominator. What value x makes x minus 7 equal to 0? So I can set that equation up, add 7 now. And I'm seeing that x equals 7 would create a division by 0 here. So that's my excluded value for this one. So I'll just state that up front. Excluded value is x equals 7. So that's this piece. Okay, so I'll actually do that right up front. Now for the simplify part. So I'm going to factor the GCF out of the top. Okay, maybe something I'll do even before that is get x's first. Since that's going on down here, I'll kind of just get the order right. So 28 minus 4x over x minus 7. This would be exactly the same as negative 4x plus 28 over x minus 7. And now what I'll do is I'll factor this numerator. So I'll factor out a negative 4. So I have negative 4 factored out front of the top, leaving behind an x minus 7. Right, negative 4 times x is negative 4x. Negative 4 times negative 7 is positive 28. So this looks like a good factorization. And I still have x minus 7 on bottom. So now I have x minus 7 as a factor, top and bottom. So I can cancel it actually. And this thing actually simplifies to, this original problem simplifies to negative 4 with the added caveat that there's an excluded value of x equals 7. Okay, so whatever number I plug into this, I'll always get negative 4 as long as that number isn't 7. So let me just show you by example what I mean. So if I replace x with a number, so 28 minus 4 times, I'm just going to pick my favorite number, which is 13. So plug in a 13 for x, and guess what we're going to get out of this? When I press equals, I get a negative 4. And that's why this thing simplified down to negative 4 every time. If my favorite number were 11, let's just go with 111. Who cares? I'm still getting negative 4 every time. The only issue would be if my favorite number were 7. If my favorite number were 7, I do not get negative 4 out of this. So that's why this is excluded. Okay, I'll leave part 2 for you, and of course I'll be posting a solution for all these. Here's another one. So again, the goal is to simplify and also state any excluded values. So I'll think about excluded values first. Again, I cannot divide by 0. So for the excluded values part, I'm thinking, okay, when does t squared minus 10t plus 24 equal 0? The solutions to this will be excluded. Okay, so our factoring technique was we take a times c. So step 1 is take a times c. In this case, 1 times 24, which is 24. Step 2 is factor a times c, looking for factors that add to b, which is negative 10 in this case. So for part 2 of this kind of how to factor step-by-step process, we take now 24, we factor it, and we look for factors that add up to, in this case, negative 10. So this is the little puzzle I'm trying to solve. So negative 6, negative 4, maybe after some thinking you'd figure that out. Negative 6 times negative 4 is positive 24. Negative 6 plus negative 4 is negative 10. So now I can rewrite this middle term in terms of these factors. So that's step 3, is rewrite bx. In this case, I'll just say bx because this is for factoring ax squared plus bx plus c. So rewrite bx using the factors we found. What I mean by that, so here's number 3 in practice for this one. I mean t squared minus 6t minus 4t plus 24 equals 0. So in other words, this negative 10 is still present. It's just right there. Negative 10t is right there. Step 4 is factor by grouping. What I mean by that is I will focus on these first 2 terms and then these second 2 terms, and I'll factor those. Okay, so factoring that looks like, okay, so as I was saying, it looks like a t is shared. So out of these first 2, I will factor out a t. So t and then t minus 6. Out of these second 2, I will factor out a negative 4. So negative 4, leaving behind a t minus 6, right? Negative 4 leaves behind t minus 6 again. And then factor out the t minus 6, which is shared. T minus 6, t minus 4 is left behind. And now I can say, okay, from the 0 product property, t minus 6 needs to be 0, t minus 4 needs to be 0. Add 6, add 4, and I'm seeing that we're getting t equals 6 and t equals 4. And keep in mind, the only thing I've done so far, all of this work, the factoring, all it has been for so far was to find the excluded values. So these are excluded values. They're not our solutions. We're not solving an equation, but part of our work is to state excluded values for this thing. Okay, so what I'll do now that I know that, so that's part of our work, I'll go back and let's rewrite this. I'm going to rewrite this as negative 3t plus 12 over this factorization actually. So sorry, this factorization. So I'm going to actually write the denominator in its factored form. So we would have t minus 6 times t minus 4. Negative 3t plus 12, it factors as negative 3 t minus 4 over t minus 6 t minus 4. Now that I have those in factored form, now I cancel these commonalities. Okay, so what we're left with in the end is negative 3 over t minus 6. This is what it simplifies to, and its excluded values are t equals 6, 4. All right, I'm leaving this one open. You're going to need to factor 4 times, right? Factor a bunch, cancel, state excluded values, all that good stuff. I'll go ahead and do this one, part 2. So this is a division problem. So maybe what I'll do first is actually turn this into a multiplication problem. Keep in mind, if you have a over b, some fraction divided by another fraction, maybe c over d, then this is completely equivalent to if we invert and multiply. So now I invert the second fraction, instead of c over d, it's d over c, and now I can just simply multiply straight across, and it's the exact same result. So in other words, I can think of this as, well, I'll write it over here, p squared minus 12p plus 27 over p squared minus 13p plus 36 times, right? So I can flip this fraction and say times instead p squared minus 8p plus 16 over p squared minus 6p plus 9. So what I'm going to do now is think of the excluded values part. So that will entail thinking about this factored and set to 0, and thinking about this factored and set to 0. Okay? Something to note. So check this out. So going back to this problem real quick, just a conceptual thing I want to point out to you guys. When we were factoring, we eventually found that the numbers that worked were negative 6 and negative 4. Notice that those numbers just simply appeared in our factorization. So I could have, as soon as I identified, oh, negative 6 and negative 4, I could have actually just written down this factorization. And that's what I tend to do when I'm doing this on my own time. That is true only when there's a 1 here. So in the cases where your a is 1, as soon as you find these numbers, these factors that work, that kind of solve this little puzzle, they will just appear here. And you don't need to go through the grouping steps. You could just write it down. So I'll do that a couple times here, show you what I mean. So what I'm now doing is trying to factor this and set this equal to 0 to figure out excluded values. So I have a 1 times 36, that's 36. Then I'm looking for numbers that add up to negative 13 in this case, right? So let's see, negative 9 and negative 4. Since this is a case where a is 1, I can now quickly write down this factorization as p minus 9 times p minus 4. I know that's what this thing is in factored form. Setting that to 0 and solving will state excluded values, some of the excluded values for this problem, right? In a similar way, if I think of this one, we again have a 1 for a times c is 9, factoring 9 so that this adds up to negative 6 in this case. -3 and -3. Because there's a 1 here, I can quickly write down the factorization as p minus 3, p minus 3. I need to think of that equal to 0 for excluded values. Okay, so I'm seeing excluded values coming from p minus 9 equals 0, p minus 4 equals 0, and these are the same term, so it's just one copy of p minus 3 equals 0. So excluded values would be, it looks like 9, 4, and 3. So maybe I'll write that over here. So excluded values would be p equals 9, 4, and 3. And what I'm going to do now is replace the denominators with the factored version. And then I'm also going to factor the numerators. This is now the simplify part. Okay, so I need to factor this thing as well. So again, there's a 1 there. So 27, 1 times 27 is 27. Now looking for things that add up to -12, and that's for this one. To factor this one, I'm looking for 1 times 16, 16, and numbers that add up to -8. So to do this puzzle, it looks like I need a -3 and a -9. And for this one, I need a -4 and a -4. So in factored form, I can now write this polynomial. I'll try to squeeze this in here. So the factored version up here, again, there's a 1. So I can kind of do this quick version of factoring. So since this factored this way, I know it's going to be p minus 3 times p minus 9, and then multiplying straight across, I'll have p minus 4 times p minus 4, running out of room, over this factorization, p minus 9 times p minus 4, right? That's what this thing was factored. And then this thing factored, sorry, that's what this thing is factored. And then this thing factored is coming from here. So p minus 3 times p minus 3. And now I can cancel all these common factors. So p minus 9, one of these p minus 3s, one of these p minus 4s. So it looks like the only things left are p minus 4 over p minus 3. So that's the simplify part, right? P minus 4 over p minus 3, that's the only thing left. And then we had already stated this excluded values part. Okay. So on to add or subtract. So we've kind of seen only multiply and divide so far. So what about adding? So to add or subtract fractions, you need the same exact denominator. Okay, so what I'll start with here is actually simplifying first. So this would be the same as 8/45 plus 3 times 2 over 3 times 5. So actually these 3's are extra, even out of the gate. So 8/45 plus 2/5. So I cannot simply add these and say like 10/50. I can't do that. Something I could do is type it into the calculator. So 26/45 is what I'm expecting. Let's see how to do it by hand. So I need to build this fraction up so that it has a 45 in its denominator. Okay, so what I'll do is I'll multiply by 9 over 9. Right, this is just a strange version of 1 here. This is just the number 1. So multiplying 9 over 9 times 2/5 doesn't actually change the value of 2/5. It's still 2/5. It's just re-representing it. So this is the same as 8/45 plus 18/45. Right, 9 times 2, 18. 9 times 5, 45. And now, once you have the same denominator, you can go ahead and maintain that denominator and then add the numerators. This is how the calculator is getting 26/45 that we saw a little bit ago. I'll try one with variables now. So I'm going all the way to page 88. Leaving some of these open for you guys. So what I'll do first, this heading just says add or subtract and simplify. It doesn't say anything about excluded values. Sorry, I'm looking here. So for example 3, it just says add or subtract the rational expression and simplify. So part 4 here is that there's that same instructions. So what I'll do first is actually factor. I'm going to kind of speed factor. So 1 times -20 is -20. And then adding up to an 8 in this case, if possible. So to do that, let's see. 4 and a 5 don't work. Adding to an 8, multiplying to a 20, it looks like a 10 and a 2. So -10. And 2, that would actually add up to -8. So I need to switch the signs. So it should be a +10 and a -2. After I have that, I can quickly write down the factorization. So it'd be 5 over m plus 10, right? This number just coming directly into the factorization. Again, it's only true if there's a 1 here. If there's a 2 there or a -1 even, you have to go through those grouping steps. And then I'll have m minus 2, this -2 here. Plus, again, factoring. So maybe over here, 1 times -10 is -10. Trying to add up to a 3 in this case. So 5, +5, and -2. So this will factor as 3 over m plus 5 times m minus 2. So now we can see what we have. We have m plus 10, m minus 2 in the denominator over here. We have m plus 5, m minus 2 over here. So the least common multiple, in other words, the denominator I want to build up to, so the least common denominator will be m plus 10 times m minus 2 times m plus 5. Okay. So what this one is missing is an m plus 10, and what this one is missing is an m plus 5. So I will multiply by m plus 5, top and bottom. And then over here, I will multiply by m plus 10, top and bottom. So I'm basically accounting for what is missing with respect to the least common denominator. So I have 5 times m plus 5 over the least common denominator, which is m plus 5, times m plus 10, times m minus 2. Over here I have plus 3 times m plus 10 over m plus 5, m plus 10 times m minus 2. now that they have the same denominator, I can actually bring them together. So I can say m, or 5m, I'll just go ahead and distribute also at the same time. I'm running out of room. And then actually at the same time as well, I'll go ahead and bring them together. So once you have the same denominator, you can go ahead and preserve that denominator and then bring the numerators together. So I then have plus 3m plus 30. So in simplified form, it looks like 8m plus 55 over m plus 5, m plus 10, and m minus 2. Okay, so on to an application. All right, example 4, it says Stefan can prepare a tax return in h hours. Stefan gets 1 over h of the job done per hour. Hopefully that makes some sense. Just to make, imagine h were 2. Like imagine Stefan can prepare a tax return in 2 hours. Then that would mean that Stefan gets 1 over 2. In other words, half of the job done per hour. Right? Which makes sense. If let's imagine Stefan does the tax return in 4 hours, then Stefan would get 1/4 of the job done per hour. So that's why this 1 over h is here. Jelena can prepare the same tax return in k hours. Jelena gets 1/8 of the job done per hour. Working together, they have this rate, 1 over h plus 1 over k of the tax return done per hour. Rewrite the expression 1 over h plus 1 over k by finding a common denominator and adding. Okay. So 1 over h plus 1 over k. The least common denominator there would be h times k. So what this one is missing is h, multiplied by h over h. What this one is missing is k over k. So this would be equal to k over kh plus h over kh. Once they have the same denominator, I can go ahead and add numerators. So k plus h over kh. Find the rate it takes the 2 employees working together to prepare the tax return. If Stefan can prepare the return in 9 hours and Jelena can prepare the same tax return in 7.5 hours. So now plugging in, I have h equals 9 and k equals 7.5. So I'll plug those in. So 7.5 plus 9 over 7.5 times 9. Type that into my calculator. So not plus, or not multiply, but plus 9 for 7.5 times 9. This is 11/45. So that would mean that working together, they get 11/45 of the tax return done per hour. All right. Talk to you next time.